In this video, we're going to be seeing some methods for solving problems involving kinematics. Kinematics is one of the ways that we use to study motion in physics. Kinematics is the purely descriptive study of motion without respect to cause. Later, we'll see that we also have dynamics. Once we introduce a causal mechanism like force or impulse, or a conservative idea like momentum or energy, something that's conserved over the course of motion, that description is called dynamics, and it has the power of being predictive. But let's start with just being descriptive. Beyond this distinction between kinematics and dynamics, we also have two ways of approaching problem solving. One is what I call synthetic, and the other is analytic. So synthetic means putting together small pieces to get to a bigger idea. And the opposite of that is analytic, breaking a big picture understanding into smaller parts to find out individual facts. To illustrate these methods, we're going to look at a concrete example. Let's consider a situation. Students in a lab measure the speed of a cobalt-plated coffee bean launched horizontally from a level tabletop. The horizontal speed of the cobalt-plated coffee bean is 4 meters per second as the bean leaves the table. So we see that it's flying off horizontally. See if you can picture these students. They have the bean on the surface of the table and they're flicking it, trying to land it in the coffee can. Notice no question has been asked yet. Let's see what the question is. If the tabletop is 1.5 meters from the ground, that's a relatively tall table, how far away should the students place a 20 centimeter tall coffee can to catch the bean when it lands? We should always start with a sketch. One difference between experienced problem solvers and novice problem solvers is that the more experience a problem solver has, the more likely they'll always begin with the sketch, and we'll see why. So here we have our table sketched, labeled 1.5 meters tall, and our coffee can 0.2 meters tall. We also know that the coffee bean leaves the table. It's headed horizontally. We see that in the text of the problem right here. We've labeled its velocity horizontally there. We also know that we don't know how far we need to place this coffee can. So now we have the information organized in a way that we can think about. I know that this coffee bean is going to arc downward this way from previous physics experience, and it'll follow a parabolic path. But what do we want to know? How far away should we place that coffee can? We can begin by listing things we know. I know that the initial height is 1.5 meters. The final height is 0.2 meters. That tells us that the change in height, delta y, is negative 1.3 meters. We also know that the initial component of the coffee bean in the x direction, Vx0, 0 for t equals 0, is 4 meters per second. And the y component, since it's moving horizontally, is 0 meters per second. And since we're on Earth, we know that g, the acceleration due to gravity, is negative 10 meters per second, or negative 10 meters per second squared, meaning every second that this coffee bean can fall, it's going to gain 10 meters per second of downward speed. Now we can finally apply a problem-solving approach to figure this out.